Greetings dear friends, welcome back to my YouTube channel, Tech. It's really been long, no video has been uploaded for microcontrollers, but today we will proceed with something very interesting and brief, easy to understand programming of PIC microcontroller. It's going to be different from the previous one we've been seeing. As you can see in this video, we have a PIC16F877A. In the previous videos, I've been programming 84A. So please, if you're a newcomer, subscribe to the channel so that you get to see the other YouTube videos and also be able to do these connections here, because I'm not going to be repeating them in the videos. So let's see basically what this code and simulation here does. So what this code and simulation here does is to count from 1 to 16. As you can see, it has started already. That is 5, 6, 7, 8, 9, 10, 11, 12. So it's going to count like this right up to 16 and start back after that again, right up to 16 and start back. Yeah, it has been done already, but in this first code is without this push button. Yeah, we are going to modify the code to show you that it gets the push button once the push button is pressed before it starts counting. Yeah, so if the push button is not pressed, all of them will be off. So let's get to serious stuff. So today we'll be programming this PIC16F877A, not using MPLAB, previous software. No, what we'll be using today basically will be micro C. Yeah, it helps us code in C program. That's called our microcontroller C program. So let's get started and open our micro C. As you can see, it's my own version. Okay, once the micro C is open, you get to new project. Yeah, once you have new project, yeah, we want the standard project. You want the Visual TF, the if next. Yeah, right now you give the name to your project. Yeah, in my video I'm going to give it my project, and yeah, you choose the device name. There are so many of them. So basically I'm working with the 16F877, and yeah, you work with the frequency you want. Yeah, so I'm using 1 megahertz, and you choose the folder where your work is going to be saved at the browse button. Yeah, I want mine to be saved at desktop, so from there I'm going to say next. So now, for now, in this video we're not going to add any file, but in the next complicated projects we are going to be adding maybe files in the previous code. So for now, just say finish. So once you are finished, here is the way it looks like your micro C. Yeah, here we have your build button. Here you have your save. Here you have your save all. You use save all when you have so many files aligned here. Yeah, and here's our project in which we are to write. Basically, apart from that, with time we are going to be seeing other stuff like the library manager. Yeah, we're going to use it when we'll be doing the case of button in this same video. So for now, let's just start with the coding part. So this code here, I'm going to write it in the video so that you get to understand each step and line. So let's get back to our simulation. If you get to notice in our simulation, we use register port B. That's we use RB0, RB1, RB2 and RB3 as output. But we have an input at RB7. So let's get back to the micro C. If we have an input at B7, so to initialize right now there are pins whether they should be input or output. We're going to use trace B. You guys are familiar with that from MPLAB. In micro C you don't need to initialize trace B. It recognizes trace B already as a keyword. So we're gonna set this guy. That will be 0 by 80. 80, that's in hexadecimal. 8 because RB7 takes an input, so it needs to be a 1. So trace B has been initialized. You set port B, all of them should be at 0, 0. That they should be low. Initially they should be low. After that, right now, before they start counting. So in MPLAB we're creating our looping using labels, but for this case here we are not going to make use of labels. We're going to make use of an infinite loop, that is the while one. This while1 here means once the PIC microcontroller is executing, it should be performing what is in this braces for while1, and we are the one to decide on what it should be performing. So basically, as you guys saw, it was just incrementing by 1, right? That's it was counting. So if you just want to increment, you still use your port B equals to port B plus 1. Yeah, you see, right? So initially port B is at 0, after I put a plus 1, so it places a plus 1. After the plus 1 now, it continues with the execution. So here we're going to use a delay subroutine in the micro C itself. That is always in milliseconds. From there you can put, I want 1000 milliseconds, that refers to 1 second. That is all about our code. That is effectively all for the code. So getting back to the explanation, you set here, you set them as input or output. We have only one input at RB7. Then while1, they talk about port B increments plus 1 each time it is being executed, and you have a delay of 1 second before the next action takes place. So let's build our code. If there's any error, it's going to tell us. Okay, basically we didn't close the braces for the void main, so let's close it before we proceed and build our code again. Yeah, once you build it right now, it has been saved already, so you build it again. So let's come right now to the uploading in Proteus. So many people just found it difficult, while it's always in our videos. So let's keep track by subscribing to the channel already. So to upload our code, I saved mine as desktop. Yeah, you see, right? Once you build it, a hex file is being created where you saved the work. So yeah, I have my own hex file already. I'm just going to upload it by double clicking. Then I say okay. From there I run my simulation. So basically you see, right, it's exactly what is performing. Initially all the LEDs are off, that's you put them at 0, 0, and after that they start incrementing right now by 1 right up to 16, after which they'll continue the process again from 1, that's 0, 1, and so on and so forth. So basically that's all for this part. So let's get to see right now the next part with the push button. Okay, this next part now with a push button. To add a push button here is just too simple and straightforward. You use your if statement, that's a button. This button is a keyword, only one condition, and you use this AND, this AND operation. That's that port B that our push button is found. Since at port B our push button is found, yeah. Here right now I need to precise which of the pins at port B is found. For our case in this video, it's at RB7. If you can take note, push button is at RB7. So RB7, here right now, you precise that when it is being pressed high. From there, you close your braces and you create your if statement. You see, right? If this is this, then it's performing this. That this operation will be performed only if the button is pressed. So we got right now else. This else is not compulsory, but better you put it else port B, all of the LEDs should be off. So once they are off, you close your else statement. That is all. Once we are going to build this, we are going to find an error here. The error right now will be that button is not recognized. So to solve this issue, right, there's a register. You get to view library manager. At the library manager right now, you're going to find it here. At library manager, you're going to find system libraries, and at system libraries right now, you have a whole lot of libraries. So we need to select the library for button before it's going to recognize that in our code. Yeah, I need to select the library for button before it recognizes that in our code. And after building now, you see, right, building now, the error is not more. And after building, the hex file in our desktop has been. Okay, sorry for that misunderstanding. Actually, I had my time limit for recording. So let's get back to a simulation uploading that of the push button. See how it behaves. So basically I saved it at desktop. So I get to desktop, here's a hex file. I double click or I click once and come and say open. From there I say okay and execute my code. So you see right now for this case, the lights are all off because we haven't yet pressed on a push button. So basically that's what this code does. Let's press right now the push button. You see right, it starts counting once you press on the push button. So thanks you guys for watching the video. Make sure you subscribe to keep track on the next videos which are going to be uploading. I assure you they are going to be wonderful, because in the next videos we are going to be dealing with liquid crystal display in Proteus with these PIC microcontrollers and some kind of sensors, yeah, with an optocoupler. So just subscribe to the channel, make sure you keep track to all the videos we'll be doing. Thanks very much for watching. Please at the comment section if you have any question, it will be answered in the next video. Road up tech.